So, for this problem, we have a 50-gram marble is moving at 2 meters per second. So we're going to draw that in our coordinate system to the right. 50 grams, 2 meters per second, and it's going to hit a 20-gram marble at rest. So this guy is 20 grams. What is the speed of the 50-gram marble immediately after the collision? So, we're going to have some sort of collision where we have marble number 1 is going to go this way, and marble number 2 is going to go this way. So this guy's the 50-gram marble. It's going to bounce off. A perfectly elastic collision, and the 20-gram marble is moving at 2.857 meters per second. So, with our current knowledge of just momentum conservation, we can't actually find this value, but next week's class, we will learn how to find this value and not have it be given to us. So that's pretty cool. But right now, we're just going to use the value that's given to us and use what we know, which is the law of conservation of momentum. So, we have our before and after pictures. So I'm going to separate them by a dotted line. So before, we have the 50-gram mass, 2 meters per second, and the 20-gram mass, 0 meters per second, because it's at rest. Keep putting our dotted line. And then after, we have the 50-gram mass, an unknown velocity. That's what we're solving for. And the 20-gram mass has a velocity of 2.857 meters per second. So, to find the momentum of each one of these guys, we need to just multiply our masses times our velocities. So, 50 grams times 2 meters per second gives us the momentum initially of ball 1, or marble 1, of 100 grams meters per second. And then initially for this guy, the marble number 2, 20-gram one, it has an initial momentum of 0 because it's not moving. So, to find the total initial momentum, it's P initial 1 and P initial 2. So that is equal to P initial 1, P initial 2, and that is equal to 100 grams meters per second. So our initial momentum is a known value. So, if we want to find P1 final, that's 50 grams times an unknown velocity in grams meters per second. Our other ball has P final 2. Let's fix my notation here. P final 1. P final 2 is equal to 20 times 2.857, which if we plug this in, 20 times 2.857 into our calculator, we get the final momentum of the second one is 57.14 grams meters per second. So, keep our dotted line. P final is equal to P final 1 plus P final 2. So that is equal to 50V plus 57.14. So if we scroll down, our law of conservation of momentum says that P initial equals P final in all collisions. So 100 grams meters per second is equal to 50V plus 57.14. So that means 100 minus 57.14 is equal to 50V. So 100 minus 57.14 in our calculator is 42.86 equals 50V. If we divide both sides by 50, we get that V is equal to 42.86 divided by 50. 0.8572 meters per second. Note, this is a positive number, which means if we go back to our diagram, this guy is drawn incorrectly because we have it going in the negative direction. What our diagram final actually looks like is this guy has a small velocity and this guy has a bigger velocity. So the 50-gram ball is moving to the right and the 20-gram ball is also moving to the right. So this is 2.857 meters per second. And our final answer was 0.85 meters per second. So both of the balls are moving in the same direction, which is unlike something we've seen before. So make sure you keep your signs in check.